Hello, and today will be the second lecture of this course, and we will take initial two lectures to understand what is meant by simple C programming. We will assume that most of us have done some programming in a language which need not necessarily be a C language, so we will utilize some time to just get acquainted with the constructs of C language. And C language is a language which provides a large number of facilities to the programmer, a large number of high level facilities for data structuring as well as programming methodology, as we discussed in the first class. And today we will see some of the simple constructs. Later on we will move into the more sophisticated and complex constructs of C language. So today will be an introduction to C language, which we shall see by running certain example programs which are there on the computer. I will assume that you are aware of some programming language, and therefore we will just take a set of graded examples so that we go through how to do each and every aspect of programming in C. So let's go and see what happens. We'll be executing it on the HP machine out here, and we will see how to some examples. The first example that we will see is this. So a C programming language will have a main function declaration. Okay, so this is unlike other languages like Fortran, where you do not require to name the main function or the main program. In C you have to call it main. The arguments which can be given here are certain arguments which we shall see later, and we shall leave them blank for the time being. Now here we include a file, and this is a library which is the input-output library of C. Now C has got a huge set of libraries, and along with C language you have an input-output library which is called the standard io.h. So we call it in short stdio.h, and for all our input and output programs we use this stdio.h. So we include it in our programs. C is a block structured language, and in every block can be defined by these braces. This is one brace, and this is the brace which is the opening brace is here, and the corresponding closing brace is here. And we will see the concept of blocks. Every main program must have a block. So here we define a block for the main program, and inside this block we have a sequence of statements. So this is the structure of a simple C program. Now in this example we just print something. So the print function is called printf. This prints into the standard output if you don't give any other arguments. You can also use file printing functions which are also available. We shall come to it later on. Now in a print statement, whatever text item has to be printed will be given within these quotes. This is one quote, and this is the ending quote here. So within the quotes, whatever you want to get printed will have to be printed. And other than here we have written our first try. So we want to print our first try, and this \n is a control sequence into the print statement. This control sequence means here \n means new line. So after printing our first try, it will give a new line. So let us see how this program works. So when we run it, it gives our first try. Now we could have put another \n here and here. Then what would happen is that after printing R, it would give a new line and then print first try in the next line. So if we execute this, here I am compiling the program with the CC compiler. CC is the compiler, and it creates a .a.out file which is executable. So this a.out file has to run, and you'll see our is now printed first, our, and then first try in the next two lines. if we look at our program again, we will see there are several other than this \n, you can give other constructs. One of them is t, which gives a tab. So if you give \t, it will give you a tab between hour and first. To see how this executes, hour, and then there is a gap for tabbing, and then first try. So this is a simple program which just prints something, and hopefully we will be using this print statement again and again. So the first thing in any programming language is to write and read. So here we have learnt how to write in C. Now we will see the next is how to write out the value of a variable. So let us take the second program. Here we are going to write down the value of a variable n. So we've again included stdio.h. We've got a main program within curly braces, and here we are using a variable called n. Now this variable has to be declared, unlike Fortran, where depending on how the variable is named, the type of the variable is assumed, and there is a default type, though you can also declare a type of a variable. In C language, you have to declare the types of each and every variable. And we have declared n to be an integer, and the format for declaring n to be an integer is int n. Similarly, we will see how to declare a real number, how to declare a character, how to declare strings, and how to declare arrays a bit later. But now we will just work on integers for the time being. And here we have assigned n equal to 5, and we have printed the value of n. So we have written printf, the value of n is equal to, now here is a %d. This %d is another control construct. It gives you the format in which the variable will be printed, and %d means it will be printed as an integer. Okay, \n, comma n. So this is the, between the two quotes from here to here is the control sequence of the complete control of the printf statement. It says first the will be printed, after a blank value will be printed, blank n equal to, then an integer will be printed, after a blank there will be a new line, and corresponding to this integer we will print this value of n. So let's see how this program will run. It prints the value of n is equal to 5. Sorry. Now we could also change the value of n, say to 6 here, and we could include another variable, say m, declare it, and assign m is equal to 8, and print the value of m here also. And for this we will have to give another %d So this means it will print the value of n is equal to, it will print the value of n, and in the next place it will print the value of m. So if you want to write m also, then you will write like this. So it will print the value of n equal to, and it will give the value of n here, and then m equal to the value of m here, because first n and then m will be printed. So this is the program. Sorry. There is some mistake oh, there is an I out here which is incorrect. This is syntax error. So it has given a syntax error during compilation. So now it's okay. So it now prints the value of n is equal to 6, m is equal to 8. And if you want them in different lines, you can put the control n and the other sequences as and when they are required. So now let us take the next program. The next program, so we have seen a program to simply print. We have seen another program to declare variables and print their values. The next program that we will see is reading. How to read the value of a variable. In the previous program that we did, we just assigned the value of a variable to a fixed value and then printed it. Now we will read it and print it, because reading and writing is the first thing that you should know well in anywhere, in any language, whether it's Fortran or English. So this is a program to read an integer and print its value. So it says hash include stdio.h main. This is the main braces. We declare an integer int n. We print saying give an integer, and here there is no backslash n, so it will wait here for you to give an integer, and this is the function to read a value. Like printf, scanf is the library function which can be used to read a value, and just like printf, it has a control within these quotes which says that I am going to read in an integer %d, and when I give the integer, very funnily, I have to give with the variable something called and n. If I give only n, the results will not come. So I have to give something called and n to actually read in the value of n. We will understand why we have to give and n a little later on. But let us see how this program works first. So if we have to read in a value n, we have to write in, and if it's an integer, we have to write in scanf %d and n, and then printf, we are just printing the value of n, as you can see in the normal manner. So let's see how this program runs. So we have compiled it, scan.c, that was the name of the file, and the executable is a.out. So it says give an integer, and if we give 8, it prints the value of 8. Again 10, it will give the value of 10, and if you give 8.9, it will give you 8, because it is supposed to read in an integer, and if you give a decimal number, it will truncate the decimal number and read it. So we will see what percentages formats mean when you give a real number and it is supposed to be read as an integer. It will just truncate it, as you can see in this example. It does not matter whether you give a negative value or a positive value, all of them will be read. So let's go back to the program and see what we were doing. So we were reading something and printing it. Now let's come back to the intriguing question of this AND. This AND is related, see this scanf is a function, okay, and this AND is related to how parameters are passed in C language. We shall come to how parameters are passed a bit later on. For this information, AND n means the address of the location n. Now let us understand this a bit better before we proceed further. In the computer, you will see that variables are stored finally. If you have variables, they are, after compilation, during execution, they are storage locations in the memory of the CPU. So the computer has got the simple von Neumann architecture, can be looked upon as the CPU and the memory. And here the program as well as the data is stored. Now corresponding to the variables, data corresponding to the variables are stored in the memory. So corresponding to every variable n, you have a memory location. Now this memory location has got two items. One is the address of this location, and the other is the value inside this. Now whenever in C programming language, whenever you write x is equal to n, then this means the value of x is assigned the value of n, or in other words, the value of n is copied into the value of x. So whenever we use value statements, we mean, whenever we use a simple variable, we mean the value of a variable. Whenever we write and n, we mean the address location of the variable n. So and n means the address location of any variable n. And suppose somebody passes an address location a to you, and if you want to know the value of this address location, you write star a. So if a is an address location, if you want to find out the content or the value of that address, you write star a. So there are two things about a variable. If it is a variable, then and a, if it's a variable n, m, a, then and of it will give you the address location. If it's an address location, then star of it will give you the value. So these are two things which are used extensively in C. And here, let us come back to the program now. In the program, this and n means you are passing the address of the location n. Why you have to pass the address of the location n is a question we shall answer a bit later when we come to functions. This is related to the parameter passing rule, and once we come to functions and pass parameters and change variables, we will realize why it is like this in C. So for the time being, let us just know that whenever we have to write a scanf function and we have to read in the value of a variable, we have to pass the address of that variable, and the address of that variable is passed by the and n statement. Any questions? So now we move on to a more involved exercise where we are using some assignment statements. So this is a program which finds out the roots of an equation. Now we will be using some functions. That is why I have included another library other than the IO library. I have included the math library. The math library includes some functions in C. So I have got only one main program. We have not come to subroutines yet. So inside this main program, I have now declared float a, b, c, r1 and r2. Float declares a real number, a floating point number. Like int declares an integer, float declares a real number. Semicolons, as I did not mention, semicolons break up statements. Float a, b, c, r1, r2. A, b, c are expected to be the values of the coefficients of a quadratic equation, which is given as ax squared plus bx plus c, and r1 and r2 are the roots that we are expected to find, and we will take in some real numbers. So first thing we have to read in is the coefficients a, b and c. So how do we read in the coefficients? Scanf, and since they are floating point numbers, we read them by the percentage f format. So percentage f, percentage f, percentage f. If you give a blank here, then you will have to read in a blank as well. If you give a comma here, you will have to read in a comma as well. So normally they will accept it with blanks, and if you explicitly give a blank, you have to also explicitly give a blank. If you give a comma here like this, then when reading in, you have to give a comma. We will avoid all those things. So percentage f3 floating point numbers, and as mentioned earlier, we are going to read in and a, and b, and c. So to read in a, b and c, we pass the addresses of a, b and c, and then we compute the roots r1 and r2, assuming that complex roots will not be there and other issues will not be there, assuming that the inputs will come correctly. We give r1 is equal to minus b plus square root of b square minus 4ac divided by twice a, and r2 is minus b minus square root of b square minus 4ac by twice a, and then we print out root 1 and root 2. So the first thing, when you run this program, you are supposed to give in the 3 values. So let's compile it and first and then run it. Sorry, this will not give the correct result. I have to compile it with the math library included. So there is in Unix, you have to compile it with minus -lm format. That is why. So let's give the 3 values: 1.0, 2.0. So with the inputs 1, 2 and 1, the roots are 1 and minus. The 2 roots are equal roots, and both of them are minus 1, and you can give other values to see what you will get. With a equal to 1, b equal to 3, and the other one, you will get this. So this is a simple statement where we have used assignments. We have used the square root function out here, sqrt. You have got a whole lot of other inbuilt mathematical functions, sine, cos, and everything else is available like in any other language. Only thing is you have to include the math library, and you have to compile it so that the math library is included properly and is loaded. In Unix, you have to compile it with the minus -lm option, and in the Windows or the DOS, you have to compile it appropriately. So, however, this program does not take care of the issues when the roots are equal, separating out the cases when the roots are equal, when the roots are complex, and the roots are unequal. That is, the 2 real roots are there, complex roots are there, and the equal roots are there. So now let us see how we will separate out the 3 parts. In order to separate out the 3 parts, we need the conditional statement or the if statement. So there is an if statement in C language as well. Here is the program which does that. So here I have included stdio.h. I did not compute the roots, so I did not include the math library. Float a, b, c, r1, r2, y, z, w. Y is equal to, I have scanf, percentage f, a, b and c. Y is b square minus 4ac. If y is equal to 0, printf equal roots. Else, if y is less than 0, complex roots. Else, there are two distinct real roots. So this is a program which uses an if then else statement, and a nested one that too. I am sure all of us understand what is a nested if then else statement. So I am not going into the details of what nesting means and what nested if then else means. The else is related to the closest if, that is the standard practice. But please note here, the equality is not y equal to 0. You must give two equal signs like I have given here to test for equality. And if you give y equal to 0, it will assign y to 0. In C language, you can make an assignment even inside a conditional. So if I had written here y equal to 0 instead of y double equal to 0, it would have assigned y to 0 also. So the equality testing is y equal to 0, else y less than 0, else the two distinct roots. So this is the simple if then else format, and I am sure we understand this if then else format as well. So now let us see the complete program with the printing of the equal roots, printing of the complex we won't print, printing of the distinct roots. So let's see the let's run this program first. Let us run this program. So if we give 1, we will get equal roots. You can also give integers. If you give integers, they will be converted to floating point. For example, you can give also this. There is no problem. It will read it properly. So if you give 130, it will print two distinct roots. And if you give, say, things like 111, it will give you complex roots, because b square minus 4ac is now negative. And the complete program will look like this. So I have done a scanf. I have computed b square minus 4ac. I have computed twice a out here, and if y is equal to 0, I print equal roots, and I print the value of the two equal roots, which is minus b by w. Because b square minus 4ac is 0, therefore it must now be minus b by twice a, and I have pre-computed twice a out here to get. So b by w should give me the value of the root, and there are two equal roots. If y less than 0, it is in the same format as the previous program, just the computation is done. It just prints complex roots, else it does the square root of y. Y was b square minus 4ac, if you notice here, and so it does the square root of y, and here it does b minus z by w. W is twice a, computed here, and here it is b plus z by w, and the two roots are printed. It prints equal roots. It prints the two distinct roots. With 130, we got the two distinct roots. Here I did not compute, because in the program it just printed complex roots and did not do anything else. Another point I would like to raise, let us go back to the original roots program. It is a very simple issue, but I would like to raise this issue right at this point so that we remember it as we go ahead. Is here, in computing the two statements, I have done this square rooting twice. I have done this b square minus 4ac twice, I have computed twice a twice, 2 star a, and this is going to put in more effort, and obviously it is going to take more time to do this computation because we are repeating computation, and since efficiency is something that we are seeking to achieve in a good program, we should try and see that we are not doing such things repeatedly. Therefore, it would have been much better if we had used a variable, because 1 or 2 variables will not make much of a difference unless you are using too much space which is not there. And here we will use more space to save on time, and we will declare a variable and assign it precompute b square minus 4ac, then we will precompute the square root of that, and then we can precompute twice a, and then use it as and when required. And that's exactly what we did in the final program. Here we precomputed the value of b square minus 4ac, we precomputed the value of twice a, and here because y was to be checked, so this value of b square minus 4ac and twice a were to be used repeatedly, once here, and the square root was to be also used twice, so we computed it only once, stored it up, and we used it. It is not, the computer is so fast that it will not be possible to show the difference in the two at this point of time, but I hope we all understand that there is going to be quite amount of difference in these two things. So this is another simple program to work out the roots of an equation, and we have seen what it means to write an if then else statement, and we have also seen how to do an assignment, declaring of integers as well as floating point numbers. And the other conditional construct that everyone uses in any programming languages is the loop. So we will now see an example to find out to use the loop. So the next construct that we will do is the for statement. There are many ways of looping in C language, and the for statement is a very flexible and quite a general purpose routine. It depends on your taste of which loop you will use. There is a do statement and there is a while statement also. There are 3 such looping constructs available in C. This is the standard looping construct where you have got very lot of control. For example, you want to go from I to n in steps of 1 or steps of 2 or steps of 4, then the for statement for fixed looping is very useful, whereas for lot of conditional looping, the do and the while statements are useful. But the for statement can also be used for conditional looping. The for statement is quite flexible, and so we will see the for statement for looping next. The next, after seeing the for statement for looping, we shall see how arrays are declared, and finally we shall see how functions are declared in C language. So we will stop this lecture here at the conditional statement, and in the next lecture we will start off with the loops, especially the for statement. Then we will see examples with arrays, and then we will see how functions are working.